Um, Hello everybody. So in this course, we will use a very well-known circuit simulator. It's called LTSpice. Okay. So what you have to do is, number one, I'm gonna give you this link in lab number 4. Okay. So once you click this link, you will find this is you will see this page here, LT Spice, which is fast and free simulator. Okay, like any other simulator, you can draw the circuit, and then you can find the current and voltage everywhere. Okay, um, you can see here once you in this page here, you can see you can download from here for Windows 10, or you download for Mac operating system. Um, so what after that, after you download the program, it's free as I told you. And once you run it, what you should see here is let me see. Yeah, that's what you should see. Okay. So once you open the program, that's what you are gonna see here. Number one, you can see here file, and then you can see new schematic, or you can just press this one here. Okay, new schematic. Okay. Now you open the file here. The first thing I wanna make the purpose of this video to give you very fast tutorial. Okay. So you can see here we have some components here. One of the components here, this is a voltage source. Okay. So once you click on this one, you can see you're gonna get a voltage source here, and then you are gonna have another one here. So in order to cancel this one, you need to press escape. Yeah. Okay. So this is a voltage source, and this also was if I right click on this one. Okay. You can write here whatever the DC value you want for this one. For example, I want to make it 5 volt. Okay, if it has if you want to make it with an internal resistance, in case if it is non-ideal, you can put the resistance here. There are some advanced things we may not need it for now. Okay, maybe this is very advanced things. Let's do like a very simple. Let's do very simple voltage source. Okay, just a source that has 5 volt, as you see here. Then I press OK. Okay. Also, we have here resistors. So once I click this one here, I have a resistance. So then if you need one more, you can click one more here. Every time you click, you will get a resistance. Once you, for example, let's have three resistance. Okay. So for example, once you press escape, okay, so you are gonna uh, uh, now you are free to do something else. Okay, for a resistance, if you just right click here, you can see you can put here the value of the resistance. For example, 5k, 5,000. Okay. Also, there are some advanced things here we may not need in the beginning, like tolerance, okay, like the power rating. Also, if you select here, like select resistors, there are some here. You can see some practical resistors. They are here. Okay. So now you can see now this is R1 and it's 5K. Same thing. I can do it here. For example, here I can say like 3K. Okay. For this one, sorry, for this one here, if I come here and click, so this one can be like, for example, 10K, whatever number you want. Okay. There are other things here who have like a capacitor, as you see here. Oops. Okay. You can actually move this one up this way. Okay. Also, you have here inductor. So this is something we are going to teach in one chapter. Other thing is here like a diode. This is something we're not going to teach in this course. Um, Also, we have a ground here. I'm going to show how you connect the circuit. But this one here, this is, let's see, it's written here component. So you can find mini component. Let me click. So once I click here, you can find mini component here like transistors and other stuff. So I'm not gonna like switches, transistor and other stuff here. So as op amp as well. Okay, so many other component. For example, if you want to put like a current source, yeah, this one can give you a current source. Also, it has dependent sources, and so all of them are here. For example, if I click on current source, I place it. So now I have a current source this way. Press escape, and then once I click this one, I can write the value of this current, like for example, one ampere, for example. Something like that. If you want to delete anything here, press in your keyboard, press delete first, and then you can see scissor here. So once you cut delete here, let's delete this one, let's delete this one, let's delete this one. Okay, let's make like a very small circuit now. Okay, so you can see here we have something like here, for example, move. So if you, how can you get anyone to how can you move in any component here? You can click this one, move, and then I'm gonna select this one. So now you can see it's moving. Okay. So for example, also how can you rotate it? So once you are moving it here, I think you can, yeah, you can come here, you find rotate. So now I can rotate it. So now I'm showing you how I can make a circuit. Same thing here. If you wanna, for example, first move. So I'm gonna select this one to move, and then if you wanna rotate it, you can rotate it. But I wanna make it like a parallel resistor. Same thing for this one here. I can say move. Okay. 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 Now, what I wanna do right now is okay. Let me press escape first. Okay. So now I can make wiring, connecting wires. So here there's a wire this way. There's a wire here this way. For example, this way here. Okay. And then click. And then I have also one wire this way and go all the way until here, and then I can move here. Okay, and then I can move this way. Okay, and then move here. From here also I can move here as well. Okay, so now you can see I created a circuit here. Let me see here. Okay, I created a circuit. As you see here, this one is 5K, 3K, 10K ohms, and the have a voltage source was 5 volt. Don't forget to add ground as well. So here, in order to add a ground, so I can put ground here, and then I can, after that, I can use make connection. So this is the reference point, or this is oops. Yeah. So this is the reference point. Now I created the circuit this way. I put here, as you see, 5K, 3K, and so on. Let's now run the circuit, okay? Run the simulator. So in order to run the simulator, you have to press this one, configure analysis first. As you see here, we have different types of analysis, okay? So we have transit, AC analysis, DC sweep, noise. So we have different types for sure. Maybe not in circuit one, you are not going to learn everything here for sure. So but let's start with a very simple thing. We call it DC operating point. So this one is actually computing the DC operating point, treating capacitor as open circuit and inductor as a short circuit. Okay. For sure, this is something you will learn more in the future. But just once you select this one, you can just say okay, and then you can put this one anywhere here. Okay. Now, again, this is the kind of analysis I'm gonna do right now. We call it DC operating system. Okay. Then I can run here, as you see here in this icon, run and pause. Okay, so once I run, I got the result is here. So let's see what result is we got here. The first thing here, the voltage of node number 1 is 5. The voltage of node number 2 is 1.57, whatever. The current of R1 equal this value. The current of R2 equal this value. The current of R3 equal this value. The current of V1 equal this value here. Okay. So, okay, where is node 1? Where is node 2 and so on? So if you come here, if you just close this one and see, if you come here, as you see here, if you just hover here in this point, if you see what's written here, look in the bar here. Okay, so once I put the cursor here, you can see this node is node number one, and it actually gives you the voltage of this node. If I move here, okay, now it's moving, so now it's node two and so on. Okay, if you come here, I think this is a ground. Okay, it's written here, this is a ground. Okay, let me do it again because I want to show you something here. So for the voltage sources, when you find the current it is negative, so what it means? It means the current actually from negative to positive. Okay, um, because as you will see shortly, if the current flows from positive to negative, this current will be positive. So you can see here, guys, of voltage here. There is one thing also I want to tell you, because if you don't like use names like node 0, node 1, you can actually put name here. So I can right click here and I can say place look this one here. Okay, so here I'm gonna okay, oh, sorry. Yeah, so here what I did here, I just put, I put I can change this one. So here, like I can put a measurement here, like here, for example, I can put the current if you want. So I can put here, if I select the current, okay, okay, sorry, you need to delete this one here. Okay, so actually it's giving you the current here, okay. If you wanna the voltage, like for example here, voltage number one, yeah, you can, oops, I think I have to delete something here. I have to delete this one here, okay. So you have the same thing I can do if I say here, okay, so here this one is giving you the voltage. So the voltage here is 5 volt, the voltage here is 1 point whatever, okay. I think, let me see here, you can put, yeah, if you can put something, if you need to put the current as well, yeah, you can come here and select like IR1 if you want. But I think you need to delete this one here. Okay, you can see we have a problem here. Can we do rounding, because it looks very bad to be this way? The answer is yes, you can. Let's see how can you do rounding. Okay, for example here for this one here, this one is actually IR1. To round this value, you need to write here round, and then you have to multiply this value. For example, I want to make it in if you want to round it, for example, let's see what's going to happen. I'm going to multiply it by 1000, and then I will divide by 1000. Okay, you see? Okay, so now you can see, now it became in milliampere. So it rounded to negative 1 milliampere. If you want it like in micro, for example, you can make it 1 million here and put 1 million here. Okay, let's see how it looks like. Yeah, so it's negative 684 microampere. Same thing for the voltage here. Okay, let me see how. Yeah, so here for this voltage. Yeah, so here I need the voltage of node 2. Okay, but I can see here round. And then after I see round, I can see I can multiply. Look here, if I need only two digits after the decimal point, so I'm gonna multiply this one by 100, and then I have to divide it by 100 this way. You see, if you need it like 3 digits, so 1000 and 1000, okay, and so on. If you need only one digit, you can multiply by 10 and you divide by 10. Okay? Anyway, um, one more thing also I want to teach here. You can actually, because maybe in a big circuit, it will be difficult to like easy. It's not going to be easy to locate node 1, node 2, node 3. Actually, you can name. Let me see how I'm trying to remember. How can you name? How you can? Let me see how. Yeah. If I come here, yeah, I think, yeah, label net. No, it's not label net. Let me see here. Um, yeah, here. So once you come, for example, let me see if I can delete. Yeah, I can delete this one. Okay, I can delete this one as well, and then escape. Okay, so what I can do here, I can come here this way, and then I can say label net. And for example, I'm gonna call it E. So here what I did here, I'm gonna name this one node A. Okay. When I come to this one here, I can also name it, this point, I can name it, but for sure, I'm gonna change it, the name to B. Okay. So now I name this one A and B. This is gonna be much easier than using node 1, node 2, and so on. Now I can run the simulation and see how it will be different. Look here. This is the voltage of A, voltage of B, the current of R1, the current of R2, the current of R3, and so on. Okay. As I told you here, the current here is negative because it's flowing from negative to positive, so normally it has to be negative. If I put, for example, let me show another circuit. For example, I'm gonna delete this circuit here. Okay, I'm gonna delete this one. I'm gonna delete this one. I'm gonna delete this one, and then I'm gonna add another source here. For example, I'm gonna add a source here. Oops. Here, let me, something is wrong here. Okay, let me move it down. What is move here? Okay, yeah, move. Okay, sorry. Let me delete them again. So I'm gonna delete this one. I'm gonna delete this one. Okay, and then let me delete this one. Let me delete many things here. Okay, and now I'm gonna get a source this way. Okay, and for example, I'm gonna make this source is actually like, for example, 3 volt. 3 volt. Okay, now I'm gonna connect the circuit again. I'm gonna connect this one this way. Okay. Okay. Yeah. And then I'm gonna also put the ground here as well. Yeah. So as you see here, what I did right now, we have 2 sources here, because this source is bigger than this source. So the current actually is gonna flow, this way. So now let's run the simulation. Yeah, you can see right now, I have the voltage of node A, okay, which is this voltage here at this point. I have the voltage of node B, which is node B is here. Also, I have the voltage of N1, which is actually this one here, by the way. Okay, you can name it as I did. For example, I can name it as you see right now. So I'm gonna make it C, for example, C. Okay. Yeah, I'm gonna put it here. This is C. Let me run the simulation again. Yeah, so now you have voltage A, voltage B, voltage C. Okay. What I want to bring to your attention, if you see the voltage, is a current of V1 and the current of V2. V1 is actually negative because current is going to flow this way from negative to positive, but here this time is going to be from positive to negative. The part that may confuse you is actually the current in R1 and R2. As I told you before, any current can be positive or negative based on what direction. What is the direction here? Okay. So if the direction this way, for example, and the current is positive, so this direction is okay. Okay. Otherwise, if it is negative, means in the other direction. However, I did not find a way here to figure out how, or it seems to me LTSpice does not give you which direction here is the currents. But it's not a problem because simply the current is gonna flow from high voltage to low voltage anyway. So if this negative, again guys, what I want to say is that this negative or positive, it depends on what direction you are assuming here, but it's not shown. Okay, I try to find some way, several ways to, it seems to me, here in OPT, in this kind of analysis, which is operating point, the DC operating point, you cannot, I'm not able to find it. Okay, but it's not a problem because, again, as I told you, you can current is gonna flow from high voltage to low voltage anyway. So if you one more thing, if I can just, if I put here, you can see the measurements here as I told you. For example, let me delete this one. So yeah, so if I come here, I can add like 3.7. Okay, same thing. You can, so once you run the circuit, even if you change the resistors. Okay. There is one more thing I want to tell you is about, you can also, here I told you we're going to use DC operating point. It's okay. Also, we're going to do something like transient. Okay. As I'm gonna teach in one chapter, transit means in the beginning. So in the first 1 second, in the first of 2 seconds, what happens in the circuit. In case of DC circuit, what happens in the first second is gonna be the same thing, right? There is no for sure, this is not the situation as I'm going to teach in one chapter when you have a capacitor. Because in case of a capacitor, it needs to charge. So the circuit will be somehow different in the very beginning. But now the circuit is not different, it will be the same thing. But I'm going to show you something interesting here as well. If you want to draw the circuit, for example, here, I'm going to say stop limit after, for example, 5 seconds if you want. Okay. I'm gonna start from 0 second, then I'm gonna go every like for 0.1. So actually here we're gonna plot this, the results. You can see here this one we're gonna stop at 5 seconds. We start from 0 second, and it's gonna collect the data every zero point 0.1 seconds. Okay. So as you see here, I can put this one here. Okay. Now we have both, by the way. So now I am doing transit analysis and also I'm doing operating point. Okay, a DC operating point. Okay, let me now run it. So now once you run it, you can see here you can actually plot. The reason I selected this one here, although we may not need in this circuit yet, but we will need in the future when we have like a capacitor. I can put a capacitor and I can show you what I mean exactly. But for now, once I come here, the good thing is if look here the cursor became like a probe. So once I click here, you actually are gonna draw the voltage here. Once I go here, you are gonna draw the voltage as well here. So this one voltage, this one voltage. The good thing here and the interesting thing, once you come here over the resistor, you can see the direction of the current assumed. So here they assume the direction is this way. You see what I'm saying? So if I click this one here, you can see the current here, which is actually negative. That means the current is going to be in the other direction. So if I come here, you can see the direction will be this way. That's why the current here, actually you can see here, the current is positive, right? The current is positive because the direction is this way. Okay. So this is also another way to do analysis. Let me close this one. Let me tell you here, maybe it's just interesting to learn something like that. So for example, let me delete this one here. Let me delete this one. And let's have a capacitor, for example. What happens is that the capacitor needs to charge in the very beginning. That's why you will see right now. Uh, let's see how it's gonna work. Okay. So I put a capacitor here. That's why transit is gonna be very interesting. But don't worry, we don't need capacitor for now. So it's gonna be in the future. It's something I'm gonna teach in the future. Okay. Oh, sorry. It gives me error, by the way. So here, when I click, it gives me error. This is because I didn't put I did not put the value of the capacitor here. So, okay, so it's something you need to learn. For example, I'm gonna make it 1. So 1 millifarad. Okay, something like that. Now I'm gonna run the simulation here, as you see. Now let's see what is. I wanna see the voltage here. Okay. Um. Yeah, I think I should have let me start from a very short period of time. Let me do this one again. So here I'm gonna stop at 5. Doesn't matter, but let's stop, for example, after 1 second. Let's start with, okay, start some values here. And 0. Let me see how it looks like. Or maybe we need to add a switch as well, but let me see. Okay, because, okay, so this is after the capacitor it charges. It charged. Okay. So anyway, I'm gonna teach in one chapter. I'm gonna teach how can we do the analysis here, so that you can see how this capacitor will charge. Okay. So just forget it for now. We're gonna use it in one chapter. Okay. Yeah. So you can see here. This is the current, right? So here the current is increasing somehow. And here this is okay, maybe because let me see here. Anyway, don't forget this capacitor for now because it's maybe you're gonna be confused. So I'm gonna teach it in one chapter anyway. So if I see here, um, yeah. Anyway, I think in one chapter we will. Let me see if I think we have a switches here. Let me see here if I have switches. Okay, switches. Anyway, I don't think we need it. I'm gonna make another video when I think we have switches here. Let me see if this one is gonna work. Okay, no, we have look here. We have too many components here. Okay. Anyway, forget this capacitor here. In the very beginning, we're not gonna use it. When once the time comes and we have it, I'm gonna make another video for it. But what I'm saying here, the purpose I want to use transit is because current is gonna flow here. Okay. So that's why in the beginning is different from what happens after that. But what I'm saying here is actually after. Okay, sorry, let me make a delete here. Is actually what I'm saying here is after the capacitor charges, not about, yeah, so it's already charged, so it's 5 volt. Okay, so we need let me here. I think we need like a switch or something like that. Anyway, we're gonna teach this one in a separate lab, but for now we're gonna focus only on, let's have another circuit here with current sources, for example. Okay, let me delete all of this stuff, most of this stuff here. Okay, so for example here, if I come here and select, yeah, current source, let me put a current source here. Okay, um, okay, and now you are gonna come here and say, for example, this one is one ampere, for example, and then we can have resistors. So I can add here one resistor this way and another resistor this way. And the value of this resistor, let's make them equal. So here, this one should be like 5K. Oops, 5K. 5K. Yeah. So for sure, you know already the current is gonna flow this way. Okay. By the way, if you wanna, okay, if you wanna, for example, if after you put it this way, and if you wanna change the direction, I think we have move here. Okay, let's see. Yeah. So here I can select this one. Okay, and now I can, after that I can, should have here rotate. I can click again to rotate again, and then I can take it this way. But let me bring this one up here, and then I'm gonna move this element here this way. Okay. Oh, okay, good. So that I can change the direction this way. Okay. So it should be this current, which is 1 ampere, should split between these two 5K. So here now I can connect the circuit. Oops. Okay. Okay. So this is the circuit this way. Let's again having the DC operating point this way. Sorry, and oh yeah, DC operating point. I'm gonna click here. Yeah, you can see here the voltage at node 1, which you can even know the voltage here across. Again, if you are confused what is node 1 and node 2, what you can do here, look, I'm just giving you another example. I can put, yeah, so here you can have, it's funny because this voltage is very big voltage because 1 ampere is too much. So anyway, so same thing here, 7.5 k volt. Yeah, this because 1 ampere is something super big and this is in kilo. Okay, same thing if you want to know the place something here. But yeah, let me see. You can change this one to the current, for example, of I3, but you need to delete this one. Yeah, 500 milliampere. Same thing. If you need to know the current here, you can put this one here. This is a voltage. You can make it current if you want, which is okay. Or me delete. Yeah. Okay. That's it. If you want to make like a transient as well, you are going to stop, for example, after 1 second. You are going to start from 0. You are going to move every 0.01, something like that. I'm going to say start. Put it here, run. Yeah. So here, for example, look here. Once you come here, you can see you can draw the voltage here. Okay. If you it looks the current here, you can draw the current here. Same thing here for it's 500. You know the current here and voltages are here. Okay. Thanks. That's the end of. One more thing before I forget, guys. This file, the file here, you can save after you make a circuit. You can simply say file, save as, and you can save it in .asc. So next time when you save it this way, next time when you open it, you can see this circuit. Okay. Thanks very much.